first thing, okay, so dealing strictly with those progressions that are on there. So what I'm basically going to do, guys, is I'll give you, hopefully these go in the same order as what's on your sheet. What I'm going to do is, like I said, I'm going to give you kind of reasons below. Now these aren't things that are going to work 100% of the time. These are just common things that link together. Okay. Now the whole given part, like not all of these are going to start with a given. Okay. In terms of you actually write out in your proof given. Some of them are going to start out with maybe like a known fact in the diagram, something like that. But after that, it's going to be kind of the same kind of thing. Yeah.
Do you write that down, or you
Just kind of fill it in on that paper you got. Okay, 'cause that's what you need to have separate anyway to kind of keep track of it. All right, now with these, okay, now like for the first one, when it says given a linear pair, this is something you'll get from the diagram. Like this is just something you see. You don't actually have to say these angles are a linear pair because you have a diagram that goes with it. All right, so this is like one thing that's under the assumption of, hey, I can look at it and tell what it is.
It's already on here.
I know, it would be reasons
Oh.
because here's how you got to act in these things, right? Basically, what I'm giving you when it says proof progression is I'm giving you common things that link together, so that, like in this case, if I saw in my picture somewhere where there's a linear pair, the majority of the time, you're going to go, oh, it's a linear pair. That means the angles are supplementary to each other. All right? The reason for that is linear pair posture. So what I'm doing here, like I said, I'm giving you, like, in the parentheses thing, like, that's your reason. So, and guys, listen, so what I'm basically doing is I'm telling you, majority of the time, these things are linked together, not all the time, because it's always in the context of what the problem's asking to prove. So again, this is just working with proof stuff, and I told you guys, the more things you see linked together, the more examples you see with like proofs, the better off you're going to be. You need to keep track of these things. So any of the ones we ever wrote, the ones that you're going to do here in a second on your own, keep track of those. Okay, so that's what's going to lead you to be able to do this. All right? And then in general, most of the time, if you say, I've got angles are supplementary, the whole idea of saying that they're supplementary so that you can create an equation where they add together to be 180. So for you going from saying that, hey, I know these angles are supplementary, then they add up to 180, that is definition of supplementary angles. All right? So where this would tie in, let's just say you had a picture that looked like something like this, and you had angle 1 and 2. I don't know what it's asking to prove. I don't care. I'm just saying, if on your problem you see a diagram and you notice 1 and 2 are a linear pair, I would expect you to have at least 2 steps based solely on that. All right. Now again, this is the majority of the time. It's not every single time you're doing this. So go, okay, if I got 1 and 2 being a linear pair, I would have a step somewhere. Remember, in terms of the whole statements and reasons, I would have a step somewhere. It could be the second step, third, fourth, I don't know where. But I'll have a step somewhere. Let's just say in this case it was the third, where I go, angle 1 and angle 2 are supplementary. So it follows the chain. Look, I'm giving a linear pair in the diagram. I'm going to have a step saying the angles are supplementary. My reason is what I put below this. Linear pair posture. All right, and then the next step would be that one right there. These things are just things that link together. All right, so this is how this progression sheet needs to be used, guys. Okay, you have to start linking these things together logically. Like look for what's given, and then suddenly go, I got 2 steps automatically I can write. Instead of just looking at it and go, I don't know what to write ever in the proof. With having this here available for you guys, it's not really a viable answer to say, I don't know what to do. All right, especially if you've got problems like now where there's going to be linear pairs there, you might have alternate interior angles that are showing up. Whatever's on that sheet is fair game. All right. Hopefully the second one is kind of an add-on to this, where it goes. Do I have this next, or do I have something after this? Yeah, there's like an add-on to this saying that if you're given this part, so like as opposed to you having a drawing there, like it actually says in the given statement, angles are supplementary. Then, like your next step is probably to go, oh, I have a check. Alright. You have this given to you, sorry about that. Then yeah, you'll do the angles are supplementary. These steps just go back and forth. You could probably just put an arrow going back and forth between them, but you could bounce back and forth between those two all day. And the reasoning for that is still a definition of supplementary angles. Like every single time that's what it is. So this is like the given part. You know this, right? And when I put given up here for the progression stuff, I'm saying this is like a known fact. It's not necessarily that's what's going to be given to you next to the word given. All right, it's just that's a known fact. Okay. Back to the linear pair. All right, next one here. Okay, so this one here too. I've got an arrow going back and forth, right? Remember that's like the if and only if thing, my conditional. That means it can go back and forth between the two forever. This deals with any time in a proof or an explanation that you switch from the congruency sign to the equal sign, regardless of which order you do it in. There's the times you're going to have to do this would be if you've got congruent given to you, but at some point you work with an equation. The only way I can plug things into an equation is if I switch it from congruency to equal. I understand they mean the same thing. This is just a little bit of terminology issue in terms of I can't substitute something in without actually saying they're equal. Anytime you flip-flop between these two symbols, all right, it's always just definition of congruency. I'll let you get away with that. Because this works for segments as well. So anytime, so if it was like for segments, which I don't have on there, but if I was switching from segments, like if I said segment AB is congruent to segment DC, all right, and then I switched it to saying the measure of AB equals the measure of DC, right? I dropped the little segment mark from it, meaning the measure. It's the same reason. Okay, and again, the only time this will come up is if at some point you're working with an equation. Like now, our equations would solely be with this kind of stuff. Or maybe if it was like a segment addition option or an angle addition. All right, but anytime you have to flip-flop between the two, that's always the reason you put it. Okay, so stay consistent, I'll put it in parentheses. Okay, just stay consistent with what I've been doing, saying reasons are in parentheses. All right, then third thing, should be that. I have both of those on there, I think. All right, so again, first thing, this is something that's either given to you, right, given, or it's a known fact, something that you can see. All right, or something that maybe in your proof you've led up to the fact that you've got two lines being perpendicular. The whole point of having perpendicular lines, for the most case, okay, majority of the time again, is if I've got perpendicular lines, that means I've got right angles. The perpendicular lines make right angles. So if you go, look, I have perpendicular lines, and the next step down you say like angle 2 is a right angle, the reason you're allowed to say that is because you have perpendicular lines. the definition of perpendicular line. So anytime a word, like a single word, is telling you what to do, it's always definition of whatever that word is. All right, and then after that, for what we're dealing with, guys, right now, majority of the time, we're going to be moving towards equations or angles being equal to each other. So you might say the right angle equals 90. Again, this isn't a step that always has to happen. It's just going to happen a lot now. And again, the reason for this word right here, this term, right angle, is telling me it's 90. So since the term is telling me what to do, it's the definition of that term. Okay, and this also works, this is just in reverse. So I've got an angle that's 90 degrees. So again, this is like the known part. It doesn't have to be given. Like it's either given or it's something that you've run into while you're doing a problem. If I know an angle is 90 degrees, that means I can classify it as a right angle. So definition of right angle. So I'm classifying it now as a right angle. And anytime you classify it as something, it's always reason-wise in terms of a formal explanation. The definition of that. And then for the last one, you go, if you've got a right angle form, that means two lines have to be perpendicular. That's the only way you can create a right angle is if you've got perpendicular lines. This is the definition of perpendicular line. Okay? So again, I've classified lines as perpendicular. You classify something as a word, definition of whatever that classification. All right. I don't know if I have the next one up there, because the next one kind of ties into what we were doing the past couple days before yesterday. But let me point this out. So your fourth thing is, should say, parallel lines. And then it's got the listing of all the angles, right? You got alternate interior, alternate exterior, and all that. Again, so the way this would be something that's either known. Most of the time, this comes from the diagram, guys. If in your picture, anywhere, from now until the end of the book, you see parallel lines, you're probably going to add something dealing with either alternate interior angles being congruent, alternate exterior angles being congruent, corresponding angles being congruent, or the same side interior angles being supplementary. One of these is going to pop up. It could be with stuff, in the next chapter we're dealing with congruent triangles. This will definitely pop up. Alright, as of right now, the only time you'll probably see it is in pictures like this, where they go, those two are parallel. You see parallel lines anywhere in the diagram, look for these angle pairs. Okay, they're definitely going to pop up. And the reason is just simply you can write one of those out. Like that is the reason. Like you finding those angle pairs, saying they're congruent, right? The reasoning behind it is simply those are alternate interior angles or alternate exterior or something like that. Okay, so there's no reason to write below that. All right, now outside of those four are going to be the main progression things. The fifth thing and sixth thing there just talk about the angle addition and when to use segment additions and stuff. But I talked about it last chapter, guys. I mean, if in your picture you see something like that, your diagram looks like that, you're probably going to add that segment to that. You're going to create an equation using that. If you see an angle, and you can note obviously that there are two angles there making a bigger one, you're going to add those two together. These are things to look for. Pictures, the diagrams tell you or lead you to at least a few steps in your proof. Whether or not you get completely done with it, that's another issue. That's up to you being able to link other things together. But if you've got this sheet, if you know how to look at diagrams correctly, guys, you're going to have at least a few steps done. Okay? All right. Now, what you're going to do, I got a sheet I'm going to give you. There are two proofs on here. It's gonna, one thing to point out, if you do it in two columns, it look like that. If you have two givens, guys, you can put them all in one step. I'm gonna, on the second one, I'm gonna separate them, just for the fact that I'm gonna separate it so that you can see where I'm using both of them. But on the second one, of course, you would have to start with what's given to you. Now, there's one thing I said you should have gone back and used that progression thing, because if I look at the fact that I've got, okay, 5 and 6 are a linear pair, like, and that's given to me. On that progression sheet, I've got two things that come directly after it's a linear pair, right? If I say, look, if you start with a linear pair, the next logical thing to say would be, what about them? They do, what would you know about those two angles if they're a linear pair? A linear pair doesn't mean anything to us. We're supplementary. Right there on the sheet, guys. This is how you need to use that sheet. Okay? So you go, okay, it's a linear pair, so 5 and 6 are supplementaries next. And then right below it, on that progression sheet, you should have linear pair postulate. So that sheet is telling you guys what things to list in order.
So you can split it up a little bit?
Yeah. I'm doing it like this because I'm going to use that other given at a further time. I can put them together, but it just so you see where I'm going to apply that to the rule. Yeah.
So you can't say that angle 5 and 6 is supplementary, and then the reason is angle 5 plus angle 6 equals 180.
No. It's because the linear pair tells you it's supplementary, then supplementary says that they're 180. So it needs to go in that. The reason is because what you're working towards, if you look at the steps they give you, you're working to get up to an equation, so the farthest thing you want to say from the beginning is the equation. Alright, so this would be definition of supplementary angles. Alright, again, this is like the progression. For normal things, if you got a linear pair, that's just what happens. You say supplementary, then they have to 180. Okay, now here's how proofs basically work. What I've done within these steps is I basically started with the given, manipulated the given as much as I could until I came to a stopping point. Okay? This is how you work with proofs. You start with the given, you mess with it as much as you can, and you stop, you move on to either another given, or you try to find something else from the picture. Alright, so in this case, there's nothing else I can really get from the picture, so I moved to the other given, which was 5 and 6 were congruent. That's my other given. Now, the only thing I know about congruent angles is that they're equal. So the only thing I can say directly from that statement is, there should be an M there, measure of 5 equals angle 6. So again, this is another thing on that sheet, right? It's on the progress sheet. You say congruency, you're going to go to equals. All right, that's the definition of congruency. Okay, and again, right there, between those two steps, I basically worked with my given, the second given, as much as I can. So again, the only thing I can do is move on to another given, but they don't have another one. Move on to the picture, but remember there's nothing else we can get from the picture because the picture is just that. Not much else I can get from it. Okay? So the only other option is for me to take my two ending points here and put them together. So I've got an equation, I've got two angles equal. The whole point of having two angles equal is so you substitute one in. Alright, so if you go through those listing of statements they have, this is the next logical one. Where all they're doing is they're taking the equation you found here, taking that 6 out, replacing it with the 5, which is allowed because I know they're equal. So that's substitution. All right, then from here, the next one, again, according to the statements they have, would be that. Now, they've essentially combined like terms there, but in this case, you actually need to put distributive property because they've put them together, but they distribute out the two. The parentheses kind of do that for you. Okay, then the next step would have been this. All right, that was division property, equality. All right, now once you're here, you go, okay, I've worked with my equation as much as I can. I've got it down to what the measure of one of those angles is. 90 degrees is a good thing because if it's 90 degrees, I can classify it as something else. So this would be the angle 5, right angle 1. All right, again, I'm telling you it's a right angle, so anytime you tell someone what it is, or classify it's the definition of whatever that word is, term, right angle. And then the last thing is with J and K being perpendicular. Which again, this part right here, that's on the progression sheet. That is. This is old equation stuff. Okay, so everything, a majority of this would come from regression sheet. Now, another thing you could do is if you're given a proof, guys, you can work backwards from proofs also. Like if I looked at this problem and I knew that I had to prove that two lines are perpendicular, I know that the majority of the time, if I want to show two lines are perpendicular, I'm going to say I've got a right angle. For me to say I have a right angle, most of the time I need to show it equals 90. I could do my last 3 steps. Now I wouldn't have them numbered because I wouldn't know how many steps to go if I was writing this by hand. But you could at least have, you know, an ending to your proof. All right, so you can work backwards on some of these. And a lot of times it helps people join things together. Like the top part's you messing with the givens, the bottom part is you messing with whatever the proof is. So, okay? All right. The last thing, I just want you to take note of a few things. Okay? Why are you good work? All right. If you did MS flow proof, if you did this one as a flow proof, this is what it would look like. All right. And the whole reason that these two lines have to come together into one thing, that's what usually screws people up with the flow proof. Okay, now, the last two things, this is something you need to practice on your own. I'm going to have extra credit problems on this next stuff on the test. But since I don't really stress it that much, I won't have it as an actual question. These are just two constructions that you guys need to take note of. This whole stuff here isn't in the book. It's from something else. But the two constructions you guys kind of need to go look at is this one. This is on page 182 in the book. So take note of that, right? Like page 182, constructing parallel lines. If I ever give you a question that says construct, when you construct things, guys, you use a straight edge and a compass. I have compasses here, like when it's time for the test, you can borrow mine, like for that one question. Or you've got your own, you can use that. But make sure you note this page. You need to be familiar with it, okay? I'll show you what it looks like, but I'm probably not going to have you guys practice it right now, okay? So constructing parallel lines, that page, all right? What it looks like is this. This would be your act of doing it. You're going to start, like on the test, if I have one of these, I would give you this line here, and I would give you that point. Okay, so the whole act would be, you would do this step. All these steps are outlined in the book, guys. Okay? Like all these steps are outlined in the book. But again, everything is being used. They use the straight edge to draw that line. That's the compass part. Okay, there's no actual protractor involved here. No just kind of drawing lines that look like they're parallel. So when I check this, I'm going to be checking for these arcs that were drawn in there. And then there's this little mark here where you're going to have it. So all this stuff, if I check it, it has to be on there. Now again, all that's outlined on the page. That's just what it looks like. That's how the process would go. Okay? I know you looked at it and you're like, yeah, I have no clue what just happened. Generally how it goes, you can see that. All right? The other one, this is on page 185, I think. Let me double check. Yeah. There's two of them. There's actually 184 and 185. They're both the same. So constructing a perpendicular line on these pages, again, the process is lined out for you guys. The book does a fairly decent job of showing you what to do. Again, I'll show you what it looks like. Take note of them. Know the pages so you can look at them. All right, but I'm not going to have like a flat-out test question on how to do them. Okay, so this one here look like this. If I had it, what I would do is I would give you a line. Okay, and then I would say, draw me a line that's perpendicular to it, or construct one. All right, and the way I would expect you to do it is, I would expect you to put 2 points on the line. Then you use your compass to measure from one point to the other. All right. The whole point of having the compass is so that these lines are the same. And then what you would do is you put a point the same distance from F that E is, so these two are congruent segments that you basically created. And then it's just an act of making two little arcs above this point, above that point. And where they cross is where you're going to draw a line through. And if you do the construction correctly, and again, all these steps, guys, they're in the book, so I'm just kind of showing you what it looks like. If you reference back to them, guys, that line should be perpendicular. It should make it a right angle. Okay? All right, so take note of them, guys. Note the pages, so 182, 184, 185. All right? Familiar with them. That's the work.